I'm going to be showing you guys my ESC design work. So here's example motor. Here's here's the 3 wires that come out of it. For brushless, it has 3 wires come out. I made in 3D my whole circuit for it. So that's the circuit for it. There's the motor, there's the circuit. And I have no circuit board in my design, no plans for one either. This will be flexible, so each one of these can move all around. It'll make it a nice, flexible, robust solution with no circuit board, which just takes up unnecessary extra space. Now these wires are all spread out vertically. They'd be able to clump together much nicer, but they're spread out just for ease of being able to see them on excess for like being able to make the connections and stuff here. But you can see basically there's 6 total MOSFETs that are in here, and I removed the top tab that's usually on a MOSFET, and then all the supporting circuitry for each MOSFET is just like a few resistors. I'm putting an LED so you can see when it turns on, and then this is a little MOSFET that acts as a low side switch to switch on the big MOSFET. Because the big MOSFET requires 10 volts gate to source to turn on, and this only requires 5 volts to turn on. So a microcontroller can switch this on, a microcontroller cannot switch this on directly. So I'm using this instead of a MOSFET gate driver. I don't think I need one, but I might find out I'm wrong. I might have to go with the MOSFET gate driver instead, but for now I'm going to try doing it this way. And so I actually did in 3D my whole ESC design. This is a capacitor for it. And I just have to make like 300 of these. It's going to be a bear. And here's the design for my actual microcontroller. This is a ATmega 2560, which is for Arduino Mega. And it's just a dead bug style. You can see that this is ribbon cable that'll just be folded and then folded again, so that all the ribbon cables will all be funneled in the same direction and all end up stacking and just flowing right off in the same direction. So if we follow one, you can see it folds once and then it folds again diagonally, and then it all comes down. And then some of them will just need to fold one time if it's already in line with this. But the ones on the side need to fold over and then across diagonally again. This one here, you can see it folds once and then it makes a diagonal fold here in order to folds over and then across, so that it all flows this way. And then it makes its way down and over. You can see this one I happen to select actually goes all the way up to the ESC. So yeah, and then I put this to block it out. You can see we blocked out how much the volume will actually be once all the wires are scrunched together properly. And then we can bring this into our main model and try to fit this onto the robot itself, which I already started doing in order to block out like the actual, that will be like the actual circuits and stuff laying out. I'm already starting to put it in there and see how it will actually fit between all the motors and cooling systems and stuff. I gotta make sure everything fits, which is gonna be hectic. And then, so yeah, we're starting to put that for each motor. We'll draw a line for the motor to the blockout, and then we'll put all the blockouts out here, and then draw lines from the motor to it with yellow lines, which is just a little extruded square. And then This is the blockout for the pulley system for each motor. Each motor requires 2 sets of compact pulleys, which take up this form factor. And each motor will have an ESC, which will kind of like this form factor. This will be the wiring, that will be the components. And so each motor has these 3 things assigned to it. And so all the motors will have these laid out all around. It'll like fill up all this, kind of like these are setting out to the side. Once we draw the lines to all of them for each motor, then I'll actually have to try to fit these into whatever space we have available, which doesn't even look like we have much, but we'll just have to find space wherever we can. Anywhere you see space, like right here is some space, we'll be putting these components in the best we can. And cross our fingers, it's going to be a lot of stuff to try to fit. It's going to be brutal. We may even have to put a lot of it like along the back and stuff, and like there's a decent amount of space in here, you can see. So there's some space like right here. You can see a decent amount of space. So we're gonna have to find space anywhere we can, like little space scroungers, looking for space anywhere we can to try to fit all this extra stuff we need now. There should be a decent amount of space like in here behind the batteries, maybe in here there's a lot of space too. But, I mean, we're running out of space quick, boys, so it may end up happening, which I warned it, this might come, that we might have to add, like, unfortunately, a little bit of a belly for more space, maybe some love handles for more space, maybe like a fat arm or muscle arm for more space, like kind of make the robot a big boy, like he just went to the buffet a lot his whole life, and that will give us all the space we need. And unfortunately, that might be necessary to be able to fit all the stuff we need to fit. So it is what it is. It seems that might be heading our way. Not sure how I would avoid that. So yeah, trying to figure that out next.